All right. Are there any questions? Yes?
Did sir use exism?
Um, I've worked on it. I haven't actually personally used it. Why?
Oh, because I'm literally stuck for I don't know why with task one with Hello World, and I don't know what are they asking me to do.
Okay.
But it's fine, sir. Can help me with that after the lecture if you want, sir.
We can check it out now. We're giving people a chance to. We're giving
Yeah,
people a
I was
chance.
just trying to go through that because sir said we can use that when like for as preparation for the test on Thursday,
Yeah.
and I have to do task one to have access to the rest of the questions. But first, I genuinely don't know how to answer task one.
Okay. Let me just double check if I can log in. Just give me a second.
Yeah.
Oh, I don't remember. Um, is it part of the Java track, the basics?
Yes, sir.
Okay. Okay, let me see if I can log in with GitHub. Do this. I'll just give it a second. Are there any other questions you want to ask? So I have completed the first task. Is this iteration 1? I think.
Yeah.
Is it this?
Wait, if that was the answer, I'm gonna be very upset because I did change it too. It's because mine says greeting, goodbye, Mars. Just wait, hello. Because I really was thinking this question. Hello, world. 1 second. Hello, world. What is it? Okay, we run it test quickly.
Yes, the memos will be posted today for both 3 and 4. For assignments 3 and 4
Oh, is
will
this for the
be.
finalists?
Yeah.
When's our term for assessments going to be marked, sir?
Say again.
Oh my god, sir. It was literally that.
Yeah. Okay.
I had to change the string. I literally made a whole new class trying to get the string trying to get that the get greeting thing. Because if you click on the test, it gave like a different type of code, which really confused me. That thing.
Yeah.
Oh my word, I'm upset. I realized it took me a whole half an hour to figure out to just change the string.
So this is actually probably useful to talk about. This is an example of unit testing. So we test that the greeter returns the string, right?
Oh, so is that testing for my input?
Yes, this is the test code. So it compiles and runs this class. So you can see over here it says new
I see
greeter.
what I was doing. I was taking that code. I
No,
was
no, no,
taking that.
no. No, so the idea is that once you've written this code, they can have a whole bunch of tests. So I think if we go to the next exercise, let's take like Markdown or whatever. There's a whole bunch of tests. There might be 5 or 6 different tests that you have to write, that you have to pass, right? Things like that. So yeah.
I'm upset.
Yeah. Sorry, Akib.
I don't know how I didn't think it was that.
Yeah, it's all good. Yeah, so actually this might be useful. So before the test, I'll post the assignment solutions for 3 and 4 will be posted today. And I'm also going to release just like a check your knowledge quiz
Yes.
before the test also be. But you'll have until Monday to really do it if you want.
Yeah.
Yeah, and then your test is obviously Thursday and Friday. Thursday to Friday. What I would recommend is start, if you find you need more time, start on Friday morning and start at like 9 a.m. because then you will have 3 hours until 12, right? If you find you're
Sorry,
yeah, go ahead.
is this for Thursday?
This is for the test. So
Yeah.
for the test, if you find you need extra time to study, try to start before 9 on Friday. Then you can spend
Yeah.
Thursday studying. Otherwise, if you're confident, I would actually recommend you do Thursday and start at like, I don't know, 12 if you can, or maybe at latest at 4 p.m.
Yeah, Thursday most likely. Some of us can only start the afternoon.
Yeah,
If you want to do Thursday because we have a math test also in the morning.
yeah. So that's why I would recommend either 12 or 4 p.m. at latest, because from 4 p.m. you'll finish, if you take the full 3 hours, you'll finish at 7 p.m. And after
Yeah.
this, you won't be very useful. So that's my personal recommendation if I were taking the test.
Yes, sir.
Yeah. So if you find you need
Sir,
more revision,
and
do 9 o'clock. Yeah?
sorry, are we gonna get feedback for quiz 2?
Yes, you should. Let me actually just see if I can't do it now. It should have automatically given you feedback. I'll just double check it for you.
Thank you.
Tutorial 2, hey, term 4. Let me just find it here. Aye, this thing's such a mess. Quiz 2. Have a look at the settings. What's the feedback? Grading and feedback. Should get. Okay, I forgot to set that. Let's just see here. Okay. Okay, you should be able to access it now. Sorry about that.
Thank you.
Yeah, so the assignment memos are going up today. We're gonna do some more revision, and then hopefully on Wednesday, we'll see how much of this we can cover. I'm going to try and do the most difficult topics, so we'll quickly rank the topics and see which ones you guys find the most difficult. And then on Wednesday, we can do like a full open question and answer session, do some code examples and stuff like that. All right.
Yes, sir.
All right. So before we get started, let's quickly talk about these topics. On a scale of, let's make it 1 to 3, 1 being the least confident and 3 being you're super confident. How confident are you all about inheritance?
In what way, sir?
Do you know, if I asked you to write a class that extends another class and use super and use this, would you be able to do it?
I'll say I understand the extends part, but when it comes to super, that's where I'm still a bit
Okay,
unsure.
so we'll give it a 2.
Maybe just the super part of it,
Okay.
because I know like extends takes some of the features of the parent class.
Yeah.
But just with super, that's where I'm still a bit
Okay.
unsure.
So we'll review super and this, because I want to make sure we hit the parts you guys struggle with the most first. Polymorphism.
I don't know where I used that in any of our assignments, if I'll be honest.
Okay. So then we'll prioritize polymorphism. Put it on 1. Static and final. Are you guys aware of the differences between static and final, and as well what it means to use static? Not really. Okay. Abstract classes.
I have a base understanding of it, sir.
Okay. and interfaces.
I think maybe interface we just did recently, and maybe we can touch a bit more on that.
Okay.
The abstract class and the static final we can maybe go over last.
Okay.
But I think you can maybe do the inheritance, polymorphism, and interface first before we go through the last two.
Okay. So then we'll say
That's okay with
here.
you.
Okay, cool. So let's quickly rank this. We'll go with inheritance first, polymorphism second, interfaces third, and then we'll do static and final, and then abstract classes last. All right. Is everyone okay with overloading versus overriding methods?
Yes.
Okay, cool. So let's start with inheritance then. Everyone ready? Everyone excited? You don't have to be excited, but I'm excited. So inheritance. When we have a general class, and this is something like a user, we'll take the eCanva example, right? Like eCanva has a bunch of different users, but they all need to have a couple of attributes, something like a username and a ability to log in. Okay, so we have this general class. Then we say we want to make more specialized versions of our user. And when we do that, we talk about extending the user class. So we might have an idea for a student like this. And the student has a couple of extra attributes like a student number, and the student can take a quiz. Okay, so what this means is that we are inheriting from the user. So essentially what we're saying is if you take the user class or the student class like this, student, we also have a user class. And the idea is that the amount of information with attributes and behaviors grows as you extend, right? Like it becomes more specialized. So we have extra information like this student number and extra behaviors like take quiz.
Making student a parent class.
No, so student is a subclass, but yeah.
A subclass.
So
it's just taking the features of the user.
Exactly, yeah.
Okay.
So we have this idea of the information increasing the more specialized you get, right? So there would be like a user at the top and then a student. Because the student can do everything the user can do and more, right? So what we have here, and the reason why I drew these bubbles is because the student, like I said, is able to do everything that the user is able to do. So everything public in the user is also public on the student. So all the methods and attributes and things that are public on the user are also public on the student. And then the student adds extra stuff like a student number and a method to take a quiz, right? So we have like a more general idea and then it grows more specific. Now Java has the rule, so the way we would do this is we would say that the class student extends the user. Okay. And typically it might be a better idea to call it a student user.
Excuse me, sir?
Yes?
But so only the public attributes and methods in user will be shown in student, not the private.
Yes, exactly. So that's 100% correct. Because if you recall, private means only the class where things are declared private may access them.
Now, why would we do that?
It's to just protect information, right? So you don't want, you have another attribute called protected that'll let you
It's
do
like if
this.
you're giving, it's like for people's IDs and stuff like that, like in the previous assignments that we were doing.
Yeah.
Okay.
So you might have like a password, like a user password, right?
Yeah.
You want to make this private so that you can't just extend user. You can't just extend user and then say like this dot password is something new. So what you want to do is everything relating to the user and to the attributes of the user, you want to make sure that all of that code is done for the private attributes so that when we extend the user, we don't have to worry about it. We don't have to worry about resetting the password or anything like that.
Yeah.
We can just say like reset password, and that's already been handled for us. And so it will run like the secure way to set the password for the user. Does that make sense?
Yes, sir.
Yeah. And so that's why we would set something like a password to private and not protected. Remember, protected you can access in a class that extends it, in a subclass. So yeah, so that's why we would want to do private, and that's part of the idea of information hiding or encapsulation. Information hiding or encapsulation. And that's encapsulation. Okay. Any questions about the basics of inheritance? Everyone okay with that? Okay. So if we go on with this and this idea with inheritance, we want to remember something that we have access modifier. So access is defined in terms of private, public, and protected. Okay. With private, this is in the class only. So top secret. It cannot be seen or even, it cannot be accessed or even seen from outside of the class. So if we have a user with the password, and if the password is private, we can't see password from anywhere outside of the class. Even if a student user extends password, extends user, we can't see the password. Okay. So the student user cannot see the password. If something is public, it means it is globally accessible. Okay. For methods, this means that anyone can call or invoke those methods. For variables, it means that anyone can change it. Okay. So your variables can be changed from outside of the class. All right. So in good encapsulation practice, anything that doesn't have to be changeable outside of the class, we keep either private or protected. And then protected, finally, is in the class and all subclasses. Okay. So if we took our example here, where we created a user and a student user, right? Private would mean, let me change the color. So private, we'll make it red. Private means here, right? This is the boundary for private. Or at least, sorry, let me undo that. Private means in here, that's the accessibility. Public means anyone can access it. And then finally, protected means that only this class and the classes that inherit from that class can access it. So this is protected. This is private, and this is public. Okay, is everyone okay with the access idea? Any
Yes, sir.
questions? All right, cool. So one of the benefits of inheritance, and this is relating to polymorphism, is that when we define a class, inheritance, when we define a class in Java, we are defining a type. Okay. When we define a subclass, we are saying that this class is a type of the superclass. Okay. So it has all of the attributes and methods, but that means that if we had a subclass and we wanted to implement the same method that already exists in the superclass, we have to override that method. Okay. So when we write the following, thing to show that we're doing inheritance, I will show you what happens in terms of the keyword super and this. So we say class, or sometimes we say public class, student user, extends user. So when we say this line, the Java compiler reads this and it says, okay, this thing over here in this box, whenever I say this, I am referring to the current object that we create. So when we have our constructor, which, if you recall, a constructor has no return type, student user, and you can take parameters if you want. We're just doing a default constructor. When we do this, we are saying that this is defined here. Okay, so this is a student user, and when we see extends, then the compiler knows that whenever we refer to super, we mean the parent class or the superclass. Okay, so that's where the context for this and super comes in. Right. So what we typically do is in our constructor as the first thing, we will call super. Because when we do this, I'm overusing this now, but when we call super, we are saying let's call the constructor for the parent. Okay, so the compiler will try to find this class over here, the user class, and then try to call the constructor for user with any parameters we might add. Okay. It also means that if there are methods that are we've overridden. Sorry. So if the user has something like user dot get info, right? If we have this, and then we override it with something like public get info in the student class, you can see how in the class interface we won't have access to the user.getInfo because the override now has overridden that. So whenever we create a student user, we only get this version of getInfo. So how do we access user.getInfo? How do we access the method we have overridden? Any guesses? We would use super. So then we say super dot get info. Okay, and that's why super is useful. If you recall, we used this for the same reason, because we used it to clear up ambiguity, right? The same way we can use super.getInfo. So if we had just said get info here, what would have happened is the recursion, right? Because it would go, okay, get info. Oh, okay, so I need to call this method and then keep looping back around and around and around. But if we say super dot get info, it knows that it needs to go into this class and find the overridden method called get info. Any questions about that?
Does super just basically take the constructor of the parent class?
It's not exactly the constructor. It refers to the parent class in general. So when you call super as a method, right? So remember, when you call a method, it's the method name with the parentheses, right? So when you call super like this as a method, it is translating it as calling the parent class like this. And if you do this, that's the constructor. Do you know what I'm saying?
Yes, sir.
Okay. Any other questions? If you're confused or unsure, please ask. Okay. So with that's pretty much what you need to know with inheritance. You need to know that when you extend something, you inherit all the attributes and the behaviors. The things that are private are inaccessible to you. Let's actually make a note about that. So inheritance. Okay. So when you inherit, you gain the attributes and methods. You cannot access the private attributes and methods. Access private in the parent or superclass. You can override methods, or you have to override methods if you want to re-implement them. You can override methods in super. And then the thing that relates to polymorphism is you can treat a subclass as super. Okay. So this comes into the type system and polymorphism. Okay. So we'll talk about types and polymorphism now. If you have any final questions about inheritance, ask before I move on. Okay. All right. So polymorphism. We know some of the rules of the Java programming languages is that we have to be able to determine the type. So everything must have a type. A type. And classes are types. Okay, let's make this a capital T. So these are the golden rules of polymorphism. Now we add another one, which is to say subclasses are types of their ancestors. Okay. So essentially what this means, we have a user, then we have another class, a student user, user. And the way that polymorphism works is because of our strict rules, where we say that a student user inherits all of the attributes and behaviors of the user. And what this means is that Java can look at a student user, and see that it is a subtype of a user. So it contains all of the attributes and things of a user. And then during runtime, when we need to treat a student user as a user type, it just says, okay, we can't have access to anything inside the student user while we're treating it as a user. Does that make sense? So if the user has a method called login and a method called reset password, right? And if the student has a method called take quiz, right? Whenever we treat a student user object as a user, we cannot access take quiz because take quiz does not belong to the user class. Does that make sense?
Yes.
Okay, so with polymorphism, you can think of it as, well, it's going to sound kind of weird, but you can think of it as like a block of Swiss cheese. And so if you have your classes, you can have like a really complicated class, like a student user, and the student user is a type of a user, and it even has like a couple of interfaces, right? Like a, I don't know, a writing interface or a graduating interface, right? And polymorphism works essentially like Swiss cheese, where if we're treating it like a user, we essentially put a block over everything except for the user details. And if we're treating it like a writing type or the interface, we block everything except for what's available in the writing thing. And then if we treat it like something that can graduate, then we only allow access to it. So we kind of add this like mask over the student. So if we treat it like a user, we block out everything except for the user, and then we deny ourselves access to it. And in this way, the compiler can check if you're trying to call any sort of methods or attributes or whatever that doesn't belong to the user while you're treating it as a user, then it can make that decision and it can throw an error. So that's how polymorphism works. All right. So any questions? Okay. Let me just double check here. We wanted to go inheritance, polymorphism, and then talk about interfaces. Okay. So if there are no questions, please,
Wait.
yeah, go ahead.
So if you want to call two things at the same time, like user and graduate,
Yeah.
would that need to be a subclass of user?
So if you wanted to do both at the same time, it would be a subclass. So you would then want to treat it as a student, because a student has access to both a graduate and a user.
Okay.
So then for example, let me actually just make a new page. If we have the student, and we have a user over here, and then we have like the graduate interface, right? So if we need to store something like a university array, right, which has like, or the system which has only users, so let me do that, then we would treat the student as a user. But if we ever did like a loop where we called things on this array, we wouldn't be able to use any of the methods that aren't related to user. So instead, we would have like, if we wanted to log in and then graduate, we would treat it as a student, because a student can both graduate and login. And if you only treated them as graduates, graduates in like an array, then they can only graduate. Okay. So do you understand what I'm saying? So users can only log in. Yeah. Right. So that's the idea of composition with interfaces. You can create like these big complicated classes that can be treated with multiple different ways. And then some of their own stuff. Yeah. Okay. So then one other thing I want to discuss with polymorphism is the concept of late binding. Late binding. And that means that if you, late binding essentially means if a method is overridden, if a method is overridden, late binding uses the last implementation, so the most recent implementation of that method. The most recent implementation of the method. Okay, so what does this mean? Well, if you had your user and your user had getInfo, like that, and then you had a student, and the student had getInfo, right? So this getInfo overrides the one in the parent. A student object, when you call getInfo, it will take the latest version of getInfo. Okay. So with late binding, it will always choose the most recent implementation. However, if you do a cast as a user, what will happen here? Okay. So if we cast it, this is a cast. Okay, so that's a cast to user. If we cast it, are we forcing it to take getInfo? Or is it going to give us this getInfo? Right. This is something we'll look at if we have time. I'll write a bit of code that does it, and we can see what happens. So let me just double check there. Binding. Yeah, okay. So with late binding, it just means that if you override something, you will take the most recent implementation of a method. Okay. It does not apply to overloading, because remember, with overloading, we're just matching the method signature. Right. So it's when you're overriding something, it'll take the most recent implementation. Okay. Let's see where we stand here. Is everyone okay with inheritance? Can I cross this off?
Yes, sir.
Okay.
Yes.
Everyone okay with polymorphism?
Yes, sir.
Okay. So now we need to talk about interfaces. Excellent. So interfaces are quite easy. Interfaces, we typically put them with a capital I, interfaces. They are a set of required method signatures. And they are always public. Always public, and they are never in the interfaces, they're never implemented. I'll just write it out. Okay, so what does this mean? It's basically a way for us to have objects that might not be related by some sort of ancestor. There's no ancestor available. We can have an interface. So if these are classes, we can have an interface with a shared set of common methods that they both implement, and then we treat them as a type of this interface. Okay, so it's just a way for us to ensure that we have the same set of public methods available with the same signatures. Okay, so an interface is just a way for us to have same method signatures for disparate classes. So a common example of this is the comparable interface. So there's the comparable. Okay, and comparable actually makes use of generics like this. And all the comparable interface says, so we typically call it interface comparable, and all it says is that there is a public method called public method that returns an integer, that returns an integer called compare to. Two. And then there is the type of another object. So that is essentially what the comparable interface says. And with generics, what we mean is that whatever this is, if this is user, right, that's just a template, a placeholder. If we say user, then a user that implements comparable is compared to user, some other thing. And then in comparable, it just says you must return -1 if the current object is less than. You must return 0 if it is the same. And you must return 1 if it is greater than. Okay. So what this means is that our array lists, if we want a sortable array list, or at least we can write a sorting method. So we can have something like sort, and then as a parameter, we can now say things that are comparable. So we say comparable array of elements. Okay. So what this is saying is that when we use comparable as a type, every single type will have a compare to method, or every single element in that array will have a compare to method. Does that make sense? So an interface is a type. And all it does is prescribe a list of method signatures, and then it might have some documentation, right? Some like documentation comments that say like you need to implement the following. All right. It doesn't actually implement anything for you. It just prescribes a list. Okay. And when classes make use of interfaces, so let's go here. We say they implement an interface. Okay. So a class implements an interface. Okay. So this is the key word over here. Right. So one of the benefits of this is that because a class we can only extend once, so a class can extend only one other class, but a class can implement as many interfaces as we want. Okay, this little asterisk is a way to say 0 or more interfaces. And in Java, an interface can also extend another interface. Okay, any questions about that? The idea being is that you would have a more generic interface like a network interface, and then you would extend it and have like a Wi-Fi interface, which might have a different set of methods that it needs, or something like a VPN network interface, which might have different things like credentials or however. All right, change region, change zone, something like that. Does that make sense to everyone? Let me just double check if there are any comments. No, I think we're good. All right, we've got about 10 minutes left. I want to make sure we get through the key things that you guys wanted to get through. So I'm going to mark interfaces as fine, if everyone's okay with it. And then we can look at static and final. Everyone all right with that? Okay.
Yes.
Right. So static and final. Static. Ugh, I can't write today. Static and final. I'll put final over here. Okay. So final is quite easy. It means the value is constant. Okay. So it means that nothing can change after final. Easy enough. So when we do constants in classes, we typically say public, static, final, and then the const equal to something. This should be a type, right? So double const. All right. Static is a bit different. Static says that this attribute, variable, method belongs to the class, not the object. Class, not object. Okay, and this is a careful distinction we have to make. When we have a class, it creates a space in memory, and in that space in memory, we load all of the variables. So if we have a class for our user, when we create an object, right, in memory, there is a space for the object that we've just created with some name, right, like username Julius. Right, so this is the object called Julius, and I have a name, a username, and so on. These are all variables and attributes that belong to this object. If we created another object, of type user over here, and we maybe said like, okay, this is another instance called Lauren. She also has a name, a username, and so on. So these are things that are unique to myself and Lauren, our two instances, but we're both users. Okay. Static means that things belong to the class and not to a specific instance. Okay, so when we call something static, like let's say static, and we'll use the constant example, final pi, right? So it's a double. Pi is equal to 3, something like that, right? What this means is that pi belongs over here and is accessible by both instances of this object. Let's actually put pi over here. So we are looking at the same constant, same point in memory, and the same constant. Okay, so if we had a method, if we had a static method which is maybe like a double, and it's get answer, get pi, get answer, right? What this means is we can either call the method get answer on either of these instances, or purely from the user. So we can actually call user dot get answer. And so there's a special requirement with with static where we can't actually access anything that is not static in a static method. Okay, so this also exists. And you can see how if something is static, it's not actually able to access anything that is not static because it wouldn't know which instance to access. So if you try and write a static method that uses non-static variables, your compiler will give you an error. It should also be noted that if there are any variables that are not final, right, like a count maybe, it means that both instances can change count, but there is only one count variable because it's static. So if we had something like private static int count, right? This means that both myself, like that, and Lauren are using the exact same variable. Okay, because it's part of the class, it's static. So if I change the count and then Lauren changes the count, that count will be changed for both of us. Does that make sense? So if I change it, if I say count is equal to 0, and Lauren then accesses count, she'll get 0. If Lauren then says, okay, count is equal to 5, and I access count, it'll be 5. All right, so that's what static means. It's not pertaining to a specific instance. It's part of the class itself. It's like a shared background, a shared context for the objects. Right. Is everyone okay with that?
Yes.
Okay. Cool. So that's about the key stuff we wanted to cover today. I see that there's about 7 minutes left till 5. Are there any specific questions? I think I'll leave abstract classes for Wednesday. Are there any other questions you have that you want me to cover on Wednesday before we do the test? Anything specific you want me to look into? Any resources I can get you? Things like that, please ask.
So I think I would just like more coding examples.
Okay.
Because I think I'm pretty good with the theory, but the coding part is a little bit tricky.
Okay, I would highly recommend you go through Exorcism.
Okay.
They've got a whole bunch of examples and things. What I would suggest is there should be like, you see these are medium, but there's also like easy questions. So there's also a syllabus where you can go through like cover strings, booleans, conditionals, and all that stuff, right? So you can kind of look at what you need. All right.
Yeah. Okay, thank you.
You're most welcome.
Also, so I just checked eCanva for the quiz 2
Yeah.
feedback, and it doesn't show like your answers or like the answer key.
Okay. I'll double check then. I think the settings are maybe messed up. I'm not sure. I'll try to fix it for you as soon as possible.
Okay, thank you.
Yeah. If it's not fixed by tomorrow, please send me a follow-up email.
Okay.
Yeah. All right. So thank you, everyone. You're welcome to stick around and ask me some more questions. Otherwise, I'll see you on Wednesday. Good luck for your test preparation. Try not to worry about it too much. I'm giving you 3 hours, but I'm budgeting the test for an hour and a half. So I'm trying to give you plenty of time. But good luck with your revision, and I'll see you on Wednesday for another recap lecture. And we'll do some actual coding examples.
Thank you. Bye.
Thank you, sir.
Bye, everyone.